Hey everybody, welcome back. So the last couple days we've been talking about solving systems of linear equations. Now, we learned how to do it by graphing, and we also learned how to do it by substitution. Now, today we're going to take a look at another strategy, which is solve by elimination. So the first thing I want you to do is go ahead and do your warm-ups here. Solve the equations, hit pause, and then start it back up when you're done to check your work. All right, let's take a look at how you did. So here we solved x equals -6, y equals 7, and x equals -4. All right, so we're going to talk about elimination. So yeah, this is a little wordy here. I'm actually going to come back to this because I think it might be beneficial to take a look at what we do first and then kind of come back to this. So what does elimination mean? First of all, elimination means to get rid of. So that's exactly what we're going to do. We're going to get rid of some of these. So we're going to get rid of the x or y value, which means we'll be able to solve for x or y. Now, what I'm looking for here are opposites. I see I've got x and x, which are not opposites. And I have 3y and -3y. Those are opposites. So what I'm going to do here is I'm going to look to see if I have an opposite here. And I do. So the next thing we're going to do is we're going to add. Okay. So our step one really is to find the opposites. And then I'm going to write or make opposites. And I'll explain that one in a future problem. So what I'm going to do is I'm going to add these. So I have x plus 3y equals -2 plus x minus 3y equals 16. Remember, eliminate means to get rid of. And if I have opposites, that means when I add opposites, they're going to eliminate. So x plus x is 2x. 3y plus a -3y is 0. -2 plus 16 is 14. So divide by 2, so x equals 7. I now have my x value. So the next thing I'm going to do is substitute, okay? So we're going to substitute this into our equation. So I have 7 plus 3y equals -2. Now I'm going to solve for y. So subtract 7, 3y equals -9, divide by 3, y equals -3. Now remember, our answer is a coordinate, so 7, -3. Now, does this really work? It does, and we can go back and check our work. So by eliminating, we quickly got rid of a variable and we're able to isolate and get one by itself. All right. Before we move on to the on your own, let's go back a page and see if we can fill in some of these steps here. Okay, so this first part was kind of already done for us, but what we want to do is have an opposite coefficient. One way to do that if we don't have opposites is to multiply, if necessary, because it wasn't for the last problem, one or both equations by a constant, so at least one pair, an x or y value of like terms has the same or opposite coefficient. So that was done for us. Now step 2, what did we do? We add. Now you can also subtract. So I'm going to show you what that looks like in just a second. We can add or subtract the equations to eliminate one of the variables. Next, we're going to solve the resulting equation for the remaining variable, and then we're going to substitute the value from step 3 into the original equations and solve. So let's take a look at that problem one more time. Okay, so the first thing we did, we found opposites, 3 and -3. We added our equations. The next thing we did was solve for x. And then the last thing we did was solve for y. Now, if you remember, I said step 2, you could add or subtract. So what would it look like to subtract? If we're to add, we want opposites. If we're to subtract, we want the same variables. So watch what happens here. Now, I'll be honest, I'm not a huge fan of subtraction here because of those negatives. I have x plus 3y equals -2, x minus 3y equals 16. So when I subtract, x minus x is 0. Now be careful here. 3y minus a -3y, add the opposite, so I end up with 6y. So now I have -2 minus 16, which gives me -18. Divide by 6, y equals -3, which is what we said right here. Now I'm going to replace my variable. I have x plus 3 times -3 equals -2. X plus -9 equals -2. So I'm going to add -9 to both sides. X equals 7. So two different ways to eliminate, one with addition, one with subtraction. All right, go ahead and try the next 3 problems on your own. Hit pause, come back when you're ready. So in each of these problems, you'll see that I went ahead and added. For me, that's just what works best for me. So for 1, I ended up with 5, 1. For 2, -1, 4. And for 3, -2, 0. So looking at example 2, you notice like I don't have any opposites or the same. So what I need to do is figure out what factors and multiples here are going to make my life pretty easy. Well, I notice if I multiply this by -3, maybe if I write it over here, it would make a little bit more sense. If I multiply this by -3, I'm going to end up with a +6, which is opposites. So my step 1, I have -6x plus 5y equals 25. Then I'm multiplying that equation, that second one, by a -3. Now, the whole entire equation. So that first equation remains the same. So I have -6x plus 5y equals 25. Now I'm going to distribute 6x plus 12y minus 42. So now I'm going to go ahead and add. So let's see, those cancel out. So I end up with 5y plus 12y is 17y equals 25 plus -72 is, ooh, I like this, -17. Divide both sides by 17 and y equals -1. So that was my step 3. So now I'm going to substitute. Now I always want to go back into the original equations. So let's see. I can pick whatever one I want. I'm just going to stick with the first one because, well, it's first. There's no rhyme or reason. So I have -6x plus 5y. Well, 5 is -1 equals 25. Okay. So I have -6x minus 5 equals 25. Add 5 to both sides. So I have -6 equals 30. Divide both sides by a -6. So x equals -5. All right, so now I'm all set. I've got my x value, my y value. Now, to save some time, I'm going to say you may want to double check your work and just make sure you're all set. So what is my solution? Remember, my solution is an ordered pair. This is my answer, and it should always look just like this. All right, go ahead and do the next two on your own problems. Hit pause and we'll take a look. Go ahead and try 4 and 5. You can either add or subtract, it's up to you. But I do want you to use elimination here. Now, when it comes time to the assessment, I'm just going to ask you to solve. But for today, let's take a look at elimination. Now, there are multiple ways to solve these, so it's really up to you. But I chose to multiply the first equation by -3. When I solved my problem, I ended up with 3, 2. Now here, little trick, hope you saw this. You needed to rewrite those so that you've got your coefficients and constants all lined up. And I multiplied this bottom one by a -5 to get an answer of 0, 3. If I look at example 3, real life example, you buy 8 hostas and 5 daylilies for $193. Your friend buys 3 hostas and 12 daylilies for $117. Write and solve a system of linear equations to find the cost of each daylily. Use the 4-step method to solve. Okay, so, all right, we got a lot of information here. So how are we going to figure this out? Well, each equation is kind of set up the same. So we're going to have the number of hostas times the cost, which is our x value, plus the number of daylilies. Oh, those are so pretty. I love them. Times the cost, which is going to be our y. And then that's going to give us our total. So our system of equations, 8x plus 15y equals 193. 3x plus 12y equals 117. Now, I can't multiply 12 to get 15 or 15 to 12. So what I'm actually going to end up doing is multiplying both of these by a number. So I like to add, which means I need opposites here. So I'm going to take a look at these two smaller numbers. So I'm going to multiply this by 3 and this one by -8. Okay, so when we distribute, we end up with 24x plus 45y equals 579. Negative 24x minus 96y equals -936. Add those buggers up. Get those cancel out. 14 plus -96 is -51y. 579 plus -936 is -357. Divide both of those by -15. I did -51. Y equals 7. So it says write and solve a system of linear equations to find the cost of each daylily. Did it ask me to find the cost of the hostas? No. So do I need to do that? No. Can I? Yes. Am I going to? Not in this situation. So I have defined my variables, wrote a system of equations, solved it, and now let's actually answer the question. The cost of the daylilies is $7 each. And they're so pretty.